Hello, everyone. We would like to solve a problem basing on the stretched string and laws of stretched strings. Let me read out the problem for you. A wire of density. So let me write down what is given for you in the problem. Density of the wire is given as 9 into 10 power 3 kilogram per meter cube is stretched between two clamps of 1 meter apart. Means if you draw a diagram for that, what do you mean by that? This is wire having some density rho, and the gap between them is given to us as how much is that? L is given as 1 meter and is subjected to an extension of something, right? So load is using a proper systems, like some load is applied on that, so it has got an extension. Delta L is 4.9 into 10 power minus 4 meters. And if the Young's modulus of that wire is given for you, so that wire Young's modulus is given for you as 9 into 10 power 9 Newton per meter square. What happens when you disturb it slightly is it makes vibration. What is the fundamental frequency is asking, therefore it's vibrating in a fundamental mode. It goes like this and comes back like this with a certain frequency. We have a formula frequency for a fundamental mode of vibration, and P equal to 1 root of tension by linear density is how much. That's the question that is asked for you, right? So if I have to solve that problem, length is already given for me, right? But tensions and linear densities are not given for you, rather other parameters are given for you. So I have to convert this data into the format that is known for us, right? So as Young's modulus of the wire is given for you, you can say the definition of an Young's modulus is ratio of longitudinal stress to the longitudinal strain. We have learned this earlier. Force itself creates the tension in the wire, so tension equal to Ya delta L by L. This linear density is mass per unit length of that wire. Substituting these two values in this formula, frequency N equal to 1 by 2L root of, in the place of tension, Young's modulus A into delta L by L by linear density mass per unit length. So L and L can be cancelled, where M is the mass of that wire itself, which can be written like volume and density, product of volume and density, basing on the definition of a density. So I can rewrite N as 1 by 2L root of Ya delta L by mass of the wire as volume and density. Volume can be written like further area into length, because wire is approximately in a cylindrical shape, and rho. So area and area can be cancelled. Finally, I get a formula N equal to 1 by 2L Y into delta L by rho and L. Now, if you look at that data carefully, what all is required is given for you in the format. L given for you, delta L given for you, Young's modulus given for you, density is also given for you. Now it's easy to solve this problem. So whenever a data is given for you in the problem, you shall now try to find out what is the formula is. How can we convert the formula into a new format so that we can use the given data? That's very important in solving physics problems, right? So let us substitute the data. That implies fundamental frequency is N is equal to 1 by 2, L is equal to 1, root of Young's modulus is 9 into 10 power 9, delta L is given for you as 4.9 into 10 power minus 4, by density is given as 9 into 10 power 3. L is distance between the two clamps, that is 1 meter. So this 9 and 9 can be cancelled. That is 1 by 2 into root of 4.9. This plus 3, when it goes to the numerator, becomes minus 3. So 10 power, Young's modulus is given as 10 power 10. 10 into 10 power minus 7, minus 4 and minus 3 by 1. Everything else is cancelled. So 1 by 2, 4.9 into 10 power 3. That is 1 by 2, 49 into 10 power 2. 1 by 2, square root of 49 is 7. 10 square is 100 and the square root is 10. That is 70 by 2. That is equal to 35H. So we have got a answer for the problem as 35H. That's how we have to solve the problem. Thank you for watching.